I've been asking for the energy of activation of the decomposition of hydrogen peroxide through catalyst. The catalyst is actually really hard to find what it is. Clean and Clear doesn't seem to want to share that, but yeah, so I went without knowing the catalyst, but I guess from the activation energy I found, we should be able to determine that. We did 5 different runs, and can't really see that first. I guess it's 3% hydrogen peroxide, and that one took about an hour and a half, or an hour 45 minutes, or something like that, to come to completion. Run 2, we decided to throw in an extra one that Beckett brought with us, and so we had 2 times the catalyst. When we went on that run, it almost half the time. Yeah, it was right at an hour that it came to completion, so it stopped bubbling completely. And but as you'll see in later, I'll show you real quick. These are kind of, the plots were all wonky because a couple of them got all weird here because the thermocouple was going all crazy and hopping all over the place. So it wasn't the most accurate thing, but we have a good idea of the heat increase during the reaction. And actually we stopped counting over here towards the ends of the lines, but so it was still bubbling during that time, but at this point the heat loss to the environment equaled the heat put off by the reaction, and beyond that point it just wasn't giving off enough heat to sustain temperature. So on this slope you would have to do a correcting factor for the heat loss, but that slope I get the line of it right there, and so that gives me the temperature increase per time on each of these reactions. Now if we go back, the first 2 reactions you can see there don't have the description next to it. You asked for that description during the middle of our run, so we ended up giving you, when it started, you'd see tons of bubbles and flake off real fast, and by the middle of it, you just get big bubbles that build up on there, and then they just come off steadily, but they're large bubbles, and then by the end of it, you were seeing just little showers of bubbles. You can see that pretty much all the way through. And runs 3 through 5 all had a insulated cover we made, which I intended to run down and get some pictures of, but I've had no time this week. I'm seriously swamped. But the catalyst, the hydrogen peroxide concentration was taken down by 4ths each time so that we could see what effect that would have on the reaction rate, which is what that slope was. I was looking for that word. I got the reaction rate because I could figure out what, how much of the percentage or the composition of the hydrogen peroxide was decreasing during that time. So I will use that to figure out my rates, the molarity per time that each run experienced, and this is in order to determine K. Now I added this slide later. K is the K for the Arrhenius equation, rate constant. So I'm trying to determine the rate constant. You can see different compositions of the hydrogen peroxide, and then you got 1 and 2 for your metal catalyst, because we had 2 amounts of it. How much was on there, I wasn't sure, but I gave an estimate in there during the calculations. It was determined that it was a second order reaction. You got a straight line during the plotting of 1 over the composition of hydrogen peroxide during time. This helped us solve for, I say us, I'm used to saying us, but I did this. This is the Arrhenius, don't even know how to pronounce that. How do you pronounce that? Is it Arrhenius? Okay. So I solved that for L and OK. Took the logarithm both sides and rearranged it to be a straight line. So you can get this nice little plot down there, and you got the rate constant, or the logarithm of the rate constant on the y-axis and 1 over t on the x-axis. And you'll have the slope of that line will be your activation energy over the ideal gas law constant. So this is how I went about making these graphs, and for each of the runs, you asked for, and I just realized this right now, I did a averaging of these, but each one of these different runs will have their individual rate constant, and it's different because each one had a different composition, and so that will help you determine how it changes, I guess, over your composition ranges. But for an average of the compositions we used, which I probably should have used 3%, because that's what you wanted to know, was the reaction rate of the 3% hydrogen peroxide, right? Well, this would have to be slightly adjusted, but I'm sure it won't be too far off. The variables, between all of them, it was maybe like a 1 kilojoule difference between all of them. So, yeah, the rate constant was determined to be 0.00726 for hydrogen peroxide. The A, which is the, it's just a constant to help, forget the name of that constant. So. A, it's just a constant to make it fit better.
Yes.
I don't know. Anyway, the activation I got was 50, I'm so dyslexic, 56 kilojoules per mole. And
Want to go, Jackie?
Not really, but
Let's take a 10-minute break, and anybody can get a drink or go to the bathroom or do both.